All right, welcome to Chapter 4, Section 3, Writing Equations in Point-Slope Form. This is for IM1 or Integrated Math 1. So just as always, I'm going to go over the front screen here. So one thing you won't see on my screen, but you will see it on your screen, you will have a due date before you see this attempt, so there just doesn't give it to me on the teacher preview. But you will always have a due date here. Attempts here, I'm on attempt number 1 of unlimited attempts. This means I can submit this assignment as many times as I would like, and I can just keep coming in and trying it over and over and over again. We don't limit that. And the number of questions here just lets you know how many are on this particular assignment. So there are 10 here. This should be the maximum. There's going to be anywhere from 1 to 10 questions, just depends on the section there. Grading policy is always best score, meaning whichever attempt is your best one is the one you get to keep. And partial credits enabled. So this means if you answer 1 of 10 questions, you get to keep your 1 question as far as the points go. Doesn't mean if you answer part of 1 of the questions that you're going to get credit for that. You need to answer the whole question to get the credit. It's just finishing some of the questions is what that means. So down here it always says once you start the homework, you must finish it before you can work on anything else. And what that means is if I click start, then on your screen, this is the other thing you won't see on my screen, but you will see it on yours, there will be a submit assignment button down here in the bottom right corner. Whenever we're ready to leave this screen, it doesn't matter if we've completely finished the assignment or not, we immediately click on submit assignment. That way, number 1, you get to see what the grade is for it. It affects the grade book. Your teacher can see what you've been working on. And the other big one is it won't lock you out of everything. If you don't click that submit assignment button and say I just go up here and I close the screen, then it's going to make me come back to this assignment and won't let me work on anything else, not even topics. So just always click that submit assignment button. Very good practice to always click that. On the side here we have explanation, example, and message center. So explanation, if I click on this, it's going to tell me I'm going to lose my attempt on this question. And that's because it's going to give me the solution to this question, not an example, this one exactly. So it's not going to give you the solution or the answer and then let you come back and type it in, but you can see a very specific example if maybe you're stuck on just this one in particular, not the entire type. Example, we'll just open up this little pop-up window and show you exactly what it is they want us to do here. So we can see they've given us a slope, they've given us a point. So first we plot the point, then from the point we plot the slope, which we'll go over again when we're working this one out a little bit here. So once you're done and you've looked at the entire example, you can close it. You can click example again. It will give you another example. So this is a different one. It'll keep giving you different examples just so that you can kind of keep looking that over. And then message center allows you to message your teacher straight from this question. So we can kind of see exactly where it is you need help because it'll attach the question that you're on to your message. All right. I think that's enough. Let's go ahead and get started here. So we have graph the line with slope -3 passing through the point 4, -1. So the main purpose here is that we're going to graph a line. They've given us 2 pieces that we need to graph a line. We need a starting point, which a lot of the time when we're doing slope-intercept, which is what we've been doing for the last few weeks, we start with the y-intercept from slope-intercept form, right? That makes sense. Because they kind of nicely named that one. Well, now our starting point is going to be the point they gave us. So we're going to go over, and I can't draw on this one, so I'll draw over here. For some reason, it doesn't let me draw on that screen with my page marker. So I have 4, -1. So if I'm thinking of the coordinate grid, I always start from the center here. And for +4, I'm going to go right 4. And for -1, I'm going to go down 1 from there. So I'm going to go 1, 2, 3, 4 to the right and 1 down. And then I'm going to place a dot there. And I need to grab the little pencil here. Boop, there's my dot. From here, now I can deal with this slope. So it says slope is -3. Remember, we always have rise over run. So we need to remember what's underneath this 3, this -3. And it's underneath every number you have ever seen. It's a 1. When we just see an integer like that and there's nothing underneath, it's not a fraction, it's a 1 underneath because dividing by 1 doesn't actually change the number. So there is a 1 there. We just wouldn't write them all that way because it would start to look pretty darn confusing if we had fractions all over the place for no reason. So it simplifies down just to -3. But this helps us graph. Now I'm going to go down 3 and write 1 from my starting point. So I'm going to come back over here, and from this starting point, I'm going to go 1, 2, 3, and then I'm going to go right 1. I can also go backwards. If I go back to my starting point, maybe I was at the bottom of the graph here and I couldn't go down 3. That happens sometimes. Instead, I can take this negative and kind of scooch it to the bottom if I need to, and I could go positive 3, 1, 2, 3, and I could go negative 1. It's just kind of going backwards, but you see how they're still in a nice line? I can still draw a line between them all, for sure. Now I can click the line tool and click on any of the lines I want that I just did, as long as they're passing through. And ALEKS does not care how many points you put on the system. You could do rise over run all the way down to the bottom and all the way up to the top. It's not going to mark you wrong on that. The main thing it wants to see is the line in the correct place. All right, let's go ahead and check and continue forward. Okay, so we're going to rewrite the equation in ax plus by equals c form. This is standard form, so it just means x and y are both on the same side, and your constant c, which is just a regular number not being multiplied by a variable, that goes on the right side. So this is just standard form of a line. So we're going to take this, y plus 2 equals negative 6 times x plus 5. Ooh, that x was funny. And we are going to kind of manipulate the numbers a little bit here. We're not necessarily solving for anything, but we're trying to solve just for the constant number here, if we can think of it that way. But what our goal is to make sure that we get x and y both on the same side. So we're going to distribute this 6 just like this. So we have y plus 2 equals, and negative 6 times x, that gets us negative 6x. Negative 6 times 5, that gets us negative 30. So now I've started to simplify this. I can't add or subtract anything else on just the left or just the right. So I'm simplified. That's what PEMDAS is for, simplifying. Now I can start to move pieces from left to right of the equation. So I want x and y on the same side, so I'm going to take this negative 6 and I'm going to add it to both sides like this. So I have 6x plus y plus 2 equals negative 30. Negative 6x plus 6x, they cancel out. One negative, one positive, exactly the same number. They're inverses of each other, or opposites, which means they cancel out. All right, so now the only thing I have to deal with is this 2. I need to take this 2 and move it to the other side because I don't want any constants on the same side as x and y. So I have 6x plus y. 2 minus 2, just like 6x and negative 6x, they cancel out. One's positive, one's negative. With these guys, they're both negative. So I already have negative 30, and I'm going 2 more negative. So it's negative 32. So if they're both negative, we add and keep the negative sign. If they're both positive, we would add and keep the positive sign. We only subtract when they're opposites, when one's negative, one's positive. And the whole 2 positives make or 2 negatives make a positive, that's only with multiplication and division. So be careful about that. I have students that mix that up sometimes. Okay, so we have put this in standard form. It's okay that there's a 6 on the front here. A few things though, and we can click on here just to make sure. I'm assuming that ALEKS is going to be expecting us to have a positive integer on the front. Oh, nope, they accepted a negative integer here. So I've seen it where they want that positive integer on the front, but they're okay with the negative integer. But they're not going to want any fractions. That's a big one. So if you ended up with any fractions here, they're going to expect us to fix those. As far as the easy way to fix those is just multiply everything by what's in the denominator. And that gets rid of any fractions that you have there. If you have more than one fraction, then you'd multiply by the greatest common multiple, I guess, of those two, or of those two denominators, just to kind of get rid of them both at the same time. So if that comes up, that's just another piece of it. But we don't want fractions here. That's definitely not part of the standard form. So let me type this in real quick. Plus y equals negative 32. And I'm doing this with the keyboard. You can hit this little button for the equals if you want to, but it lets you type it in with the keyboard too. All right. So we're going to do a line that passes through a point and has a slope of 3/4. So we did one like this. Let's see, where did I want to make this eraser a little bigger so I don't have to struggle to erase here. Okay, so, and we've done this one. I know I did this one in class with everyone where we had a point and a slope. So we've been dealing with y equals mx plus b. This is slope intercept because we have slope and we have y-intercept. So they, very obviously named this one slope intercept form because we have these two pieces. Remember, x and y, those are coordinate. So we always have a point, x, y, but we don't fill these in. We leave them x and y in the equation because that way we can figure out coordinates in the future. If I write an equation for the situation with x and y, both still variables, then I can later go, okay, well, when x is 5, what is y? Or when x is 1,000,000, what is y? I can go back and forth and kind of test this out. So that's why x and y stay x and y, is that it gives us something to manipulate a little bit there and figure out what will it be if I have this number or that number. So this is what we've been dealing with so far. Now, and this whole assignment is called point slope form. So we're going to be introduced to a new type of equation. Similar pieces, but now we're going to have a point and a slope. So if we go in here, they're still having us do it this way. So I'm going to show you how to do it this way with this one. And then on the next screen, I believe we're going to jump into point slope. So what we've been doing in class when we get a point and a slope instead of slope and y-intercept is we need to go through and find our y-intercept. So in this case, they're telling me that x is 8 and y is 7. And I also know that slope is 3/4. What I don't know is my y-intercept. So this is going to stay b. All right, so let's go ahead and write this equation. So I have y equals m x, oops, not x, I was saying x, I meant to write 8 there because I'm replacing with these pieces. So y is 7, m is 3/4 because that's my slope that they told me in my equation, or my problem here. And then x is 8 because, again, they told me my point, x, y. What I don't know is what b is. So remember, we're just doing this to find y-intercept because I need to use this form. I need slope and I need y-intercept. So if I don't have one of those pieces, I need to start working toward attaining one of those two pieces, or both of them, if for whatever reason I need to. If they give me 2 points, I'm going to end up having to find slope and the y-intercept to use this form of the line. All right, so with this one, what we want to do is start simplifying. So I want to simplify this fraction here. So remember, when we're multiplying by numbers like this, there's a 1 underneath. You can reduce first. 4 and 8, they both reduce. They can divide into each other, right? I could say 4 divided by 4 is 1, 8 divided by 4 is 2, and then I can multiply across the top and the bottom. If you don't notice that right away, that's okay. You can just multiply across the top and across the bottom. Sometimes simplifying first does truly make it a little simpler, but I know I have some students that get a little bit messed up when they're simplifying in the middle too. So it depends on which one's easier for you. If you like to simplify first and then multiply the fractions together, that's fine. If you like to multiply the fractions together, then simplify. Either way, you're still doing the same 2 steps. It just depends on which order makes sense to you. All right, so if we do this one, we get 24, right? 8 times 3 is 24 over 4. So now, if we do this one, we have 24 divided by 4, and that gives us 6. If you're having trouble with some of the basic multiplication or division here, then I definitely suggest you go into ALEKS, and when you're on the home screen, those 3 tabs that are up in the top left corner there, click on them and go down to Quick Tables and choose multiplication or division. It's just, those timed multiplication or timed division kind of homework assignments where you can actually just go through and play to help you memorize some of these multiplication facts to make this part a little bit easier. All right, so I know that this is 6 equals 7 plus b. Sorry, I need to write that more like a b instead of a 6. All right, so now I need to subtract 6 from both sides because I want to get b all by itself, and the only thing on the same side as b is 6, and it's positive. So that's why I'm subtracting it. 7 minus 6 is 1. 6 minus 6 cancels out, and b just drops down here. All right, so I have found my b. Now I can go back to my equation. It's y equals mx. Remember, these two pieces are y equals and x. The only two pieces that will change in my actual equation are slope and intercept. So slope is always next to the x, and they told us that was the part we were given before, right? I knew it was 3/4. They told me that at the beginning. We've already identified it up here. The piece that I wanted to make sure I change is the b, because now I do know what my b is. My b is +1. If it was -1, I'd write -1. So you want to make sure you bring that sign over with it. All right, so we have an equation, and it's in slope-intercept form here. So they specifically asked us to make sure it was still in slope-intercept form. So be careful about that too, because sometimes it's specifying which form it wants you to place it in. So just, whoopsie, what did I do there? That's not what I wanted. 3/4. I wasn't looking as I typed that in. So be careful as you're typing things in here so you don't do something silly like that, because that looked like a really crazy fraction for a minute with x plus 1 in the bottom with 4 here. So just be very careful about how we type all that in. All right, so let's go ahead and go to the next screen here. Okay, so we're going to graph this line, and let's see, are they expecting us to know the formula quite yet? They are. So they're finally introducing us to this point slope. Let me see, I'm going to go to eraser. I'm just going to get rid of all this stuff, and I'm going to write the point slope here at the top so that we can see it. Where'd my chisel marker go? Is that the one I want? No, that is not the one I want. Where'd my marker go? I want that guy. For some reason, I like to write with the chisel marker. Okay, so this is now point slope. Sorry, yeah, point slope. So hopefully we understand we're going to be given a point and we're going to be given a slope. They very, very obviously named these two equations, right? So we have y minus, and I'm going to do this in some funky colors here. We have y1, and then equals m. I'll do m in pink. Why not? M. Let's see if I can not mess up my color coding here. x1. Okay, so here is our equation, and I did this color coding, and I did it a little different than theirs. They did it blue and red, but that's okay. So with this one, we can see we have these 2 points here. So this is a point that they're giving us, and sometimes we get more than 1 point. It doesn't matter which point we choose, and we'll come up to that when it actually happens in here. But this is a point that we can plug in. Remember, we always should have an x and a y in our final equation, because that's how we manipulate it later. If we, just like I was talking about earlier, where if I want to know if x is 5, what is y? Well, I need both x and y in my equation. So this y1 and x1, that's the point that we're going to plug in to create the equation when we're given a point and a slope. And then this guy is our slope, right? M is always the slope in these situations. So, and I forgot to write point. So again, hopefully we understand point, slope. They named it just because we're going to have those two pieces. So if I know that this is the basic form here of point slope, and they give me this equation here, well, I can go through and I can do this same idea that I just did. I have y equals x. And I'm going to fill the rest of the pieces in here. So it's +1. If you notice, the original equation is -1. So that means that this is actually a -1. Because two negatives here, minus -1, that's how I got the +1. So make sure you're paying attention to that sign. And then it says -5 here. Well, the original equation is -5, so nothing changed there. So this is just 5. And then my slope here out in front is -4/5. So this is my slope, right? All right, so we have the two pieces we need. So let's go ahead and put this into a coordinate point here just so we can see it. So we have x and we have y. So this is now where I'm going to start. Instead of on my y-intercept, when I get a point slope equation, I'm going to start on the point and then I'm going to move using the slope. So with this one, I'm going to go right 5 and down 1. So I'm going to click on my pencil tool here and go right 5, down 1, and I'm going to put a dot there. And now with this next one, the negative can go to the 1 or the 4. It really doesn't matter which one you give it to. You can only give it to 1. So you're either going to go down 1 and right 4, or you're going to go up 1 and left 4. So when it's in the middle like that, you kind of just get to choose which one do you want to do. So I'm going to go ahead and go down 1 and right 4. So let's go over here and I'm going to go down 1, 1, 2, 3, 4. And again, if I was too far and I couldn't go over 4, I can go the other way. I could go up 1 and 1, 2, 3, 4. If you notice, they're still nicely in a line there. So that works. I can go click, and there you go. I've graphed the line using this equation. So this is just another form. I have to know where the pieces are. So we definitely want to understand where to grab the pieces from. But the y coordinate is with the y. The x coordinate is with the x. And the m is in front of x, or being multiplied by x, just like it was in slope-intercept form. We just have that parenthesis now. So still similar, it's just in a slightly different form. And we can actually turn this into point slope if we wanted to, so that it would continue moving forward. Uh-oh, did it freeze? I think it froze. Let's see, window. Oh, it doesn't look like I don't see reload the window. Okay, well, I'm just going to go over here and I'm going to reload the window. So it's going to get rid of this problem, but we're just going to go skip forward to number 5 there, just so that it stops freezing on us here. So it's the only bad thing. Sometimes my teacher preview does, in fact, freeze up. Okay, so we're going to do the same thing. We're going to write an equation this time, though. Instead of graphing it, they're giving us a point, they're giving us a slope. So same idea here. I have y equals x in parentheses. And we can set this up so we know there's 3 pieces I need to fill in here, right? That makes it a little simpler when I'm thinking of it that way. So my point, and they gave me 4, negative 4. Here's x, and here's y. Because it's the only point I'm given, it's going to be 0.1, right? So that's what these little ones mean. And I don't know if I explained that earlier. I know we've talked about it before in other classes, but in this one, whenever you see that little number dropped down, it's not an exponent. Exponents are lifted up. But when it's dropped down, it's actually part of the title. It just tells me that this is the x-coordinate from point 1. This is the y-coordinate from point 1. So that's all it means. So if I want to go y minus the y-coordinate, I have minus negative 4. Put both in there, because this is actually, and I'll make this guy blue, because that's part of it, right? It should be there when we're writing it. And we can fix it and simplify it once we get all the pieces in there. And then I have x minus the x-coordinate. There's not 2 negatives because it wasn't negative here. So just be careful about, how you're putting those pieces in. And then it told me that the slope is negative 3/2. So let's clean this guy up. We have y plus 4, because 2 negatives make that a positive, equals, my silly color coding here, I know it takes me a minute, x minus, that minus didn't change, right? But we do have the 4. So I put the plus in red because that was affected by that coordinate, so that we just remember that. It's not the original negative in the equation. So here's my equation in point slope, and again, they're very specifically requesting it be in point slope. I can write this equation in slope-intercept form. There's standard form where x and y are both on the same side, and now we have point slope. So we have 3 different types of equations that we can use for a line. Point slope and slope-intercept are definitely very useful when we want to pull information out very quickly, especially when we're going to graph, because they give us this information. About, here's my point, here's my slope, or here's my slope and my y-intercept. So it definitely gives you information very quickly there. over 2. And then we have x minus 4. All right. And you can use all these pieces. I just used the keyboard again here. Check. Perfect. All right. I think I'm going to need some space here, so I'm going to erase some stuff. Oh, my chisel marker disappeared from that keyboard. Okay, so it says in a line passing through point 83 and has a slope of -3/4. Write an equation in ax plus by equals c form for this line. So remember, this is standard form. So now they're giving us a point and a slope, but they're asking us to put it in a different type of form. Well, we still put it into point slope, and then we're going to manipulate it a little bit to get it where we want it. Just like we did on the, I think that was number 2 when we were doing that. So it's the same idea there. Sorry, I'm shuffling around making a bunch of noise here. And it also says use integers for A, B, and C. So that's the warning. No fractions, no decimals there. They need to be integers. All right, so we're going to go through and we have our point. Here's x and here's y. And then we have our slope. So m equals -3/4. So I can write this equation out. Y minus equals x minus. So let's fill our pieces in here. We have y minus the y coordinate, x minus the x coordinate, and, oops, I just realized I kind of scooched that over too far. Oh, that's not going to work out nicely. I made the eraser too darn big, so now I can't get in there like that. There we go. Ha ha ha, fixing. So I forgot to leave room for my slope, didn't I? -3/4. So that would have been on the wrong side of the equation if I put it on the left side of the equal sign there. All right, so now that we have it this way, I'm going to just switch to, one color here to make it a little easier, because we need to start simplifying this as far as we want to get x and y on the same side. So I need to figure out, simplify this so there's no more parentheses. So I'm going to go like this. I'm going to multiply on both sides, or distribute, not multiply both sides, silly me. So I have y minus 3 equals -3/4 x, because I just multiplied these two together, they just get smushed together. And then I have -3/4 times -8. Remember, there's a 1 under here, so I can multiply straight across the top. -3 times -8 is +24. 4 times 1 is 4. So 24 divided by 4 is 6. And it's going to be a positive because they were both negative to start with. So that's that. 2 negatives make a positive when I'm multiplying there. All right, now I can start to bring the x and the y coordinates onto one side. So I'm going to add 3/4 x to both sides. And I have 3/4 x plus y minus 3 equals 6, because -3/4 x and +3/4 x, those guys cancel out. I'm going to add 3 over here because I only want the x and y terms over here. I don't want any constants like that. 3/4 x plus y, -3 plus 3, they're opposites, they cancel out. We get 9. So I'm almost done. I have x and y on the same side, but the only problem is I want integers. I don't want this fraction. So I'm going to multiply everything by 4. Because what that's going to do is it's going to eliminate that fraction. So if I multiply every piece by 4, and I mean everything, not just one piece, everything gets multiplied by 4. Because I'm not really changing the equation. If I multiply every single thing by the same number, all I'm doing is inflating the equation. But I'm not changing it. Everything's just going to be inflated by 4. So with this one, if I'm thinking again of a fraction, like this, well, if I multiply, I get 12 on the top and 4 on the bottom. 12 divided by 4 is just the 3 that was left over. That's why I wanted to do that. Those 4s cancel out. So I just have 3x, y times 4 is 4y, equals 9 times 4 is 36. So this is the equation they're looking for. Although the 3/4 x plus y equals 9 is the same thing, we needed to make it so that they were integers and not fractions. So 3x plus 4y equals 36. Okay, so let's go ahead and check that guy. And we are good to go. Let's keep on moving here. Bring my eraser back up so it's a little easier to move quicker on that one. Okay, so now it says write an equation to the line below. So they're just giving us a simple line. We're not given any information, but we actually are given information. The line itself is the information. We're just not told directly what it is. We have to be able to read the graph. So if I'm looking at this and it says write an equation, it's not telling me what form. I can put it in whatever form I feel like putting it in. So if slope-intercept works better than point-slope, I'm going to use slope-intercept. If point-slope works better, I'm going to use point-slope. So let's see what we're given first before we make that decision. And I'll even put it up here too. So we have slope-intercept, which is y equals, I'll do the same color coding here. And, oh, why didn't I turn pink? It says it's pink. There we go. Mx plus, and b is our kind of completely new term here, so I'll put that in green because we don't have a y-intercept on this side, right? We have the point. So it depends on what we're given. We should be given slope no matter what. That's kind of something we need. Or something we'll need to calculate if we're given 2 points. We can calculate the slope. Remember, it's just the rise over run. It's the change in y over the change in x. That's all slope means, is how far up or down did I go to get to the next point? How far right or left did I go to get to the next point? And then this guy is the y-intercept. So y-intercept. All right, so we have our 2 pieces out here. We just need to decide which one's the best one. So let's go through and take a look at what we have here. So if I look at this point, it is on the y-axis. Well, that is the definition of the y-intercept. It's where it crosses the y-axis. So I'm given the y-intercept here, which is 0. It should always be 0 for x. I shouldn't be moving right or left. I should be on 0 for x. And then I went down -3. So this, -3, is my y-intercept. And then I'm given another point here. So I can very easily calculate the slope from this point to this point by just looking at rise over run. So if I say rise over run, and with this one I can say how far do I need to go up? So I want to be on the same line here. So I want to go 1, 2. And I went up 2, so it's positive, but I'm going to go left this time, so it's going to be negative. Now I want to get to that point, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go -8. Make sure you're counting from where the point is. So if it's not on one of the axes, you want to make sure you don't snap back over. I've had students go back over to the origin and count how far away the point is from the origin. Well, we don't want to know where it is from the origin. We want to know where it is from this one. If I'm standing here, say this was like on a city block, and I wanted to get from here to here, but I can't do diagonal, there's buildings in the way, I have to use the street system, right? So I'm going to go 2 blocks up, and then I'm going to go 8 blocks to the left. It's just a direction system. That's all this is. We do need to simplify this, though, because they can both divide by 2. So we have 2 divided by 2 is 1, -8 divided by 2 is -4. So here is our slope and our y-intercept. So we can use point slope here. There's no reason we can't. Y equals x. And I have this one. When you type this in, they are going to expect to see the negative in between here like this. So Alex will give you a little bit of grief about it if you don't put it there. It's not going to mark it wrong if you put it on the top or the bottom. It's just going to give you a little bit of grief about it, because it's kind of the proper way to write a fraction there. So just keep that in mind. If you see that it's kind of giving you a little bit of grief about, oh, the negative should have been in between, and I can actually rewrite it so that I can show you what I'm talking about, the grief that it would give you. So let's go ahead and put the negative with the 1. We'll just give it up to the 1 for right now. I know it was on the 4, but remember we can kind of transition that either way we want to. So I'm just putting it on the top there so we can see it. So if I click check, oh, see, it didn't even give me grief about it. I've had it give me grief about this before. So it kind of just depends on the problem there, I guess. But normally we want to see that negative in the middle, and that's, if you do see that warning message, that's what it's talking about. but it accepted this. If I wrote it in point slope, it would have accepted that too. If I wrote it in standard form, it also would have accepted that. However I would like to write this line, as long as my numbers are correct, it's going to accept it. All right, again, we're writing an equation for this line. So now we're not on the y-axis here. And I don't want to take a guess on this one. So this is 5 here, and I could guess that maybe this is 4.5, but I don't want to do any guessing. That would definitely not generally give us a good answer on here if we guess. Even if it looks very close to 4.5, we can't do that. We want to make sure that we're right on top of integer coordinates that we can definitely pull the numbers from. So I'm given 2 points here, so I'm going to go over here and erase really quick, just get rid of this stuff. So now I'm given 2 points. I'm going to go with red. So 0.1, and remember this is x1, y1. So 0.1, I'm given, I go to the right one, that's positive 1, and I go down 4. So positive 1, negative 4. Here's my point. Then I'm given another point. So what I do need this for, and sometimes we're going to be given a graph, sometimes we're just going to be told what the 2 points are, we need to calculate slope from this. So if I'm looking at the other point here, I have, I didn't mean to put it in there, x2 and y2. This just means 0.2, right? X coordinate from 0.2, y coordinate from 0.2. So now for this one, I'm going to go over 5 and down 2, over to the right 5 and down 2, just be more specific there. So we have our 2 points. When I'm calculating slope, and I can do this visually off a graph, and I think they're going to have us do this on one of the next problems where we're actually calculating slope without the graph. Because with this one, I can very easily count and go, okay, I have to go up 1, 2 to get to the same line, and then I have to go 1, 2, 3, 4. So I can pretty quickly from a graph say, well, rise is 2 and run is 4. But if I'm not given a graph, I can do this with the coordinates. I can say the change in y is going to be the y coordinates subtracted from each other. So I would go negative 2 minus negative 4. I want to make sure I'm subtracting them from each other. And this guy's negative, that's why there's 2 negatives. And then on the bottom, it's the x coordinates subtracted from each other. That's my run. How far apart are they? What's the difference between the two? So now I'd have negative 2 minus negative 4. That turns into a plus. Now negative 2 plus 4, well, that gives me 2 again, just like it did up here. And then 5 minus 1 gives me 4. So either way, I end up with the same thing. I'm just looking at what is the change in y? That's my rise. What is the change in x? That's my run. And I've even gone as far as going like this with students. For some reason, they seem to like this too, where I can stack the 2 coordinates and then just subtract them straight down. Sometimes you end up with the negatives and positives a little bit funky, but that's okay. So I can go 1 minus 5, and that gives me negative 4. Negative 4 minus negative 2, remember that would be a positive 2, so that would give me negative 2. Now I have 2 negatives, but what happens when I put rise over run? Well, they reduce the same way. 2 negatives, they become positive. Because in division, 2 negatives make a positive. So I still end up with 2/4. So it's just a few different ways to look at that, calculating the slope. For whatever reason, I like to stack the coordinates. It just kind of is an easy way for me to do that. But this is the equation when we're calculating slope, is we actually subtract the y coordinates on the top, subtract the x coordinates on the bottom. Make sure you're going in the same order. So I did y2 minus y1, x2 minus x1. You don't want to flip-flop that order on 2 minus 1, because then your negative signs will get messed up there. So just be careful about that. This can reduce though, because they can both divide by 2. So we don't want 2/4, we want 1/2. All right, so now we can write our equation, and we're just going to pick one of the 2 points. I labeled this one 0.1 already, so I'm going to go ahead and go with this one, but it wouldn't have mattered if I went with this one. It's perfectly fine. It doesn't matter either way. So I'm going to have y minus equals x minus. All right, let's go ahead and plug our pieces in here. So we have y minus the y coordinate and x minus the x coordinate, and then we have our slope in front of x here, just like that. All right, so now let's go ahead and reduce this just a little bit. going back and forth with my colors here. So minus negative, that's going to be positive, equals 1/2 x minus 1. Oop. I forgot to put the red 1 in there just so we can see that. All right, so there is our equation of that line. That works. And again, it says just an equation. I can put this in any equation I would like. If I wanted to change this into slope-intercept form, I very well could. But we don't necessarily have to change it. If we already have this equation of the line, we can stop as soon as we have a functioning equation with all the pieces plugged in. So this is an equation, and I can just go ahead and check it and move on here. Boop. Okay. I was thinking they were going to give us 2 points. That's why I spent so much time going over slope there, darn it. Okay, so the height in centimeters of a candle is a linear function of the amount of time in hours it has burned. So if we think about that real quick, I know that's kind of a mathy type sentence there, definitely, but a function of it meaning that it's got a very specific relationship here, and the height is very specifically connected to the amount of time that you're burning. So the longer you burn the candle, the shorter it's going to get, right? Hopefully we can all kind of picture a candle burning. The wax is melting down, so the candle's getting shorter and shorter over time. So the graph, when we graph the function, it gives a line with a slope of negative 0.3. See the figure below. So we can see, here's the kind of a basic graph. There's not a whole lot of numbers on there, but a basic graph. Suppose the height of the candle after 19 hours, so here's the height of the candle right here, is 23.3 centimeters. What was the height of the candle after 15 hours? Okay, so they're asking us to do a couple things here without directly asking us to do them. We need an equation. We need something that we can plug a number into and figure out what the height is after 15 hours. So before I can do that second part, the what is the height after 15 hours, I need to deal with this 19 and this 23.3 centimeters, because that's what I'm going to write my equation off of. So in this case, I have time is my x value and height is my y value. So I can see that they've labeled it for me. But we can also think of which one's dependent and which one's independent. So the independent variable is going to go on the x-axis, and time is independent. Whether or not the candle is burning, it's going to keep moving forward. It does not matter or affect time at all whether or not the candle is lit. But the candle being lit will be affected by time, because the longer the candle is lit, the shorter it will be, right? So that's definitely an independent variable for the candle height, and that's going to go on the y-axis. So it's getting a little bit more technical there. We've talked about independent and dependent in class before, but that's kind of how we know. If they don't give you a graph there, that's how you'd know where they would go, as you think about which one is dependent on the other. And the dependent variable is going to be your y-axis, or on your y-axis. All right, so let's go ahead and write a point here. So we have 1 point, which they kind of gave us here. So our x is 19, and our height, which is our y, that's 23.3. And then they actually told us what our slope was too, without having to calculate anything here, and we wouldn't really be able to calculate if we didn't have another point. We'd have to be given another piece here, or we wouldn't be able to move forward, because we'd either need 2 points to calculate slope on our own, or, like I said, we'd need to be given the slope outright here. We could be given the y-intercept too. If they told us that the candle was originally blah, blah, blah centimeters tall, well, originally means starting point, and y-intercept is our starting point when we're looking at a graph. So that's another thing they could have done. All right, let's go ahead and plug this guy in. So we have y minus equals x minus, all right, let's go ahead and plug our pieces in. So y minus the y coordinate, and x minus the x coordinate, and then we have our slope. All right, so this is actually an equation where we're perfectly fine to use it right from this point. We don't even need to move any farther before we start looking at that 15 hours. This is an equation in point slope form. So we could simplify it if we want to. We don't have to though. I can just start using it from here. So I'm going to use, let's see, is lightning yellow too bright? I think that's all right. I'm going to go ahead and use lightning yellow for my 15 hours. Remember, hours is time. That means that's X. I'm going to plug 15 hours in here. Okay. So let's go ahead and write this out really quick. 23.3. Me and my silly color coding. I'll stop doing color coding after this step just so that it's not too tedious here. Just so we can see, here's all my pieces. So now all those colorful pieces, the blue is the original equation. But everything else that I put in colors, the red, the pink, the yellow, all of those are things that I'm plugging into the equation here. So remember, this is our equation that we created using the information they gave us. They gave us a point, they gave us a slope. I can create an equation right off of those two pieces. Once I have my equation, I can start manipulating it a little bit by plugging pieces in. Okay, well, if X is 15, what does Y need to be? And now if we notice, Y is the only variable left. So I can solve for this for sure. So first, what I want to do is I'm going to simplify this. So I'm going to take this one, and we can see they open the calculator up for us, which is nice when they have the calculator open. So I want to distribute this guy here, okay, so that I can get rid of that parentheses there. Why isn't it working? 15 times negative 0.3. All right, so I'm going to hit equals, and I get negative 4.5. Two negatives, I know this is going to be a positive because it's negative 0.3 or negative 3/10 times 19. So negative 0.3. So be careful about that. Make sure you're paying attention to what's going into your calculator just so that you get the right information here. So there we go. So it's positive 5.7. All right. So now we're going to combine these two pieces together. So we're going to go back over here and we're going to go minus 4.5. I know that I'm writing it backwards, but the 5.7 is positive. The 4.5 has the negative in front of it. Still works out just the same. So I have y minus 23.3 equals 1.2. And now I'm going to add 23.3 to the other side because I want y to be all by itself here. So I'm going to add 23.3. I'm going to have y equals, so we'll go plus 23.3, and we get 24.5. So at 15-hour mark, the candle was 24.5 centimeters. This is still not our starting point because it had been burning for 15 hours at this point. So it's still smaller than it was. We could go all the way back to the beginning if we wanted to and say at 0 hours, if we plugged in 0 there, where would we be with that candle height? But they specifically wanted to know where it would be at 15 hours. So that's where we plugged in the 15. All right, we have one more of these guys. This is definitely a longer video here. All right, suppose the weight in pounds of an airplane is a linear function of the amount of fuel in gallons in the tank. So again, all this means is we have a relationship between the weight of a plane and the amount of fuel we put in the plane because that weighs more. So the more fuel I have in the plane, the more it's going to weigh, right? Hopefully we can make that connection. We're just thinking of these two quantities and how they affect each other. So now we have the amount of fuel in the plane and the weight of the plane. So again, we have an independent and a dependent variable. The amount of fuel in the plane, well, the actual weight of the plane doesn't affect the amount of fuel. We can put the fuel in no matter how much the plane weighs. So that one's a little bit different because we're talking about weight, but we're not talking about weight of the fuel. It's weight of the plane. So the weight of the plane does not affect the fuel, the amount of fuel we have in there. We can just put more or less in, no matter what. It just depends on the size of the tank there. But the independent or the dependent variable is going to be the weight of the plane. The more fuel I put in, the more the plane will weigh. The less fuel I put in, the less the plane will weigh. So this is definitely dependent on the amount of fuel I put in. That's why it's on the y-axis. All right, when carrying 10 gallons of fuel, the airplane weighs 2,155 pounds. When carrying 38 gallons of fuel, it weighs 2,309 pounds. How much does the airplane weigh if it is carrying 52 gallons of fuel? So now they're getting a little bit more tricky with us. Just a little bit here. Let's erase some of the stuff. So we're given 2 points, actually. We know when it carries 10 gallons of fuel, remember that's my x, that it is 2,155 pounds. This is going to be one of my points. I'm also told, there's another xy here, that when it's 38 gallons of fuel, the plane weighs 2,309 pounds. So I have 2 points here. I don't have a slope. So I need to figure out what my slope is in order to continue to that last part of the equation. Before I can answer how much it's going to weigh if it's carrying 52 gallons of fuel, I need an equation to plug that into. It's that simple. I can't move forward until I've figured out the relationship here with the formula or with an equation. So since I'm given 2 points and neither one of them is y-intercept, I'm going to go with point slope here, which means I have to calculate my slope. So I want to know what is the change in x and the change in y. So I'm going to do my little coordinate stacking thing just because I seem to like that for whatever reason. And they give us the calculator again on this one because I think we're going to end up with some bigger numbers here. So I can go 10 minus 38. Oh, I don't really need a calculator for this one, but I'll do it anyway. 38. So we have negative 28. Remember, this is my run. This is my x, my change in x. My change in y, so I'm going to have 2155 minus 2309. So my change in y, this is my rise. So this is me figuring out slope here. So I have rise over run. My change in y was negative 154. My change in run was negative 28. Well, they're both negative. So 2 negatives, that's going to make a positive. I do want to simplify this. Let's see, can this simply divide by 28? All right, good enough. We're going to go ahead and divide that by 28 here. I know it ended up negative because I didn't put the negative 28 in like I should have. So we're just going to go ahead and put this as 5.5 just to simplify that a little bit. Since we don't have to graph this, we can go ahead and turn it into a decimal. Makes it just a little bit easier to deal with. All right, let's go ahead and write our equation now. Y minus equals x minus. All right, we have a point, and I'm just going to go ahead and use my point 1 that I grabbed first. So I have y minus the y coordinate and x minus the x coordinate, and I have my slope here of 5.5. Okay, so we're going to go ahead and we're going to simplify. I'm just going to go ahead and go back to one color here, so I'm not going to keep doing this crazy color coding. So I'm going to multiply 5.5 here. So I have y minus 2,155 equals 5.5 x, because those get multiplied together, so we just smush them, minus 5.5 times 10. Well, that just means I'm moving the decimal out once. So, and I can do this on the calculator here. If I go 5.5 times 10, it's just going to move that decimal over for me. So multiplying by 10 moves the decimal to the right. Dividing by 10 moves the decimal to the left. And it's the number of zeros. That's how I know how many to move. So that's why I only moved once. All right, now we want to start. And I'm already simplifying a little bit just to make this easier. So we could have already plugged in the number like we did before. I just started simplifying it to get rid of a few things here. And since I want to know what y is, remember y is my weight. I'm going to go ahead and solve this for y. So I'm going to have a slope-intercept form of a line. Just so that when I plug in that 53 or 52 gallons, I don't have to do any other kind of not crazy calculations, but just I don't have to do any moving back and forth from the equation. I can just solve one side. So negative 2,155 plus 2,155, they cancel out. And I get 5.5x plus, so I'm going to come back over here, and this was a negative 55 plus, whoops, did not move over far enough. There we go, plus 155, and that's just going to get rid of the 55s, right? Because there were 55 on here, so 2,100 or 2,100. So now here's an equation in slope-intercept form. So I could have used this one. I can use this one. It just depends on which one you prefer to use. So I just went ahead and simplified. But I could have started plugging in from this one. This is a legitimate equation right here. All right, so now I'm going to start dealing with this 52 because they're not asking me to write an equation, but I should know I need to write an equation to do this problem. I have to write that equation to move forward. So if X, that's the number of gallons, is 52, then I'm going to fill in the rest of this. So Y equals 5.5 times 52 plus 2,100. And actually having it in slope-intercept form, I know how much the plane weighs at the beginning because my starting point is the y-intercept. It's this point on the graph here. Well, my y-intercept is 2,100 pounds. That's what the plane is going to start at. And then I also know my change is 5.5 gallons or 5.5 pounds per gallon. That's what the slope means. For every pound I add, it goes up another 5.5 pounds. So I can grab a little bit more information here for if I wanted to know what it started with from this equation. From point slope, I can grab it from a specific point, but not necessarily y-intercept. All right, so let's go ahead and do the multiplication here. So we have 5.5 times 52. So this is the weight of the fuel. It weighs 286 pounds, and then the original weight of the airplane here is 2,100. So we just need to add these two guys together, and we get, let's see, 6, 8, 3, 2. So I just went ahead and added those in my head, but we can check it real quick. So go plus 2,100, and there you go. So we have 2386. And sometimes it'll give you grief if you don't put commas in, the comma separators. It shouldn't mark you wrong necessarily, but it might give you grief about stuff like that because, again, proper way to write a number. All right, that was section 3. That was definitely a longer one there because we had to go through and manipulate some equations. So I will see you in section 4.